Deep beneath the surface of the Pacific Ocean, an invisible force is beginning to reshape the world's weather. A vast pool of unusually warm water is spreading across the equatorial Pacific. Climate models suggest this El Niño could persist into early 2027, making it one of the most closely watched climate events in years. At first, it seems like nothing more than warmer ocean water. But that extra heat doesn't stay in the ocean. It rises into the atmosphere, disrupting global wind patterns, shifting jet streams, and moving rainstorms thousands of kilometers from their normal paths. The consequences can be devastating. Monsoons weaken across Asia. The risk of major flooding increases across parts of South America. Drought grips Australia. Wildfire risks increase. Crop harvests shrink. And months later, the effects can reach every supermarket shelf as the prices of rice, wheat, coffee, cocoa, and other essential foods begin to climb. So how can a single stretch of warm ocean influence the weather of nearly every continent, disrupt global food supplies, and affect the lives of billions of people? This is the untold story of El Niño 2026. Most weather events come and go within days. A thunderstorm lasts an afternoon. A hurricane might last a week. But El Niño is different. It can reshape global weather for more than a year. And what worries scientists isn't just the warm water on the surface. It's the massive reservoir of heat hidden beneath it. Deep-sea sensors have detected unusually warm water extending over 100 meters down into the ocean. Think of it as a giant battery hidden beneath the ocean's surface. Even if the surface cools briefly, that stored thermal energy keeps feeding power back into the Pacific, allowing El Niño to grow stronger for longer. That's why meteorologists aren't just looking at today's weather, they are tracking tomorrow's climate. Every fraction of a degree in the Pacific can shift rainfall across entire continents. And that is why governments, farmers, shipping companies, and financial markets are all watching this single stretch of ocean, because history has shown us what happens when this global engine reaches full power. This isn't the first time the Pacific has done this. The 1997-98 El Niño caused tens of billions of dollars in damage worldwide. The 2015-16 event triggered severe droughts, devastating floods, widespread coral bleaching, and major food shortages across multiple continents. Now scientists are asking whether 2026 could become the next major chapter in that history. Everything begins with the Pacific Ocean. Under normal conditions, strong trade winds sweep across the equator, pushing warm surface water westward toward Indonesia and Australia. As that warm water moves west, cold, nutrient-rich water rises off the coast of South America, feeding some of the richest marine life on Earth. But during El Niño, those trade winds weaken or collapse altogether. Without winds to hold it back, a massive wave of warm water flows east across the ocean. The ocean warms the atmosphere above it. Storms form over waters that are usually calm. High-altitude jet streams get pushed off course. Suddenly, rainfall moves thousands of miles away from where millions depend on it. One side of the Pacific dries up. The other side drowns in rain. It is a single ocean shift that triggers a climate chain reaction across the entire planet. That phenomenon is El Niño. Nearly half of the human population depends on a single weather system, the Asian summer monsoon. Every year, these seasonal rains refill massive reservoirs, irrigate millions of acres of farmland, and sustain billions of lives. But when El Niño takes hold, those rains weaken. High-pressure systems settle over the region, squashing cloud formation before it can even begin, leaving vast stretches of South and Southeast Asia hotter and drier than normal. Reservoirs fail to recharge. Crucial crops like rice, sugarcane, and palm oil face extreme heat stress. Even a modest decline in seasonal rainfall can reduce harvests by millions of tons across major agricultural regions. And when the world's biggest food producers harvest less, global trade markets react instantly. Exports drop, prices soar. What begins as warm water in the middle of the Pacific Ocean ends up on dinner tables across the globe. While Asia struggles with drought, parts of the Americas face the exact opposite extreme. As unusually warm Pacific water pools along the coast of South America, countries like Peru and Ecuador are hit with relentless downpours. Torrential rains trigger destructive floods, wash away roads, and collapse critical infrastructure. Under the surface, that same layer of warm water acts like a blanket, cutting off the cold, nutrient-rich currents that feed marine life, devastating local fisheries and fishing communities. Farther north, El Niño shifts the winter jet stream right across North America. The southern United States turns cooler and wetter, sharply increasing the risk of flash floods, while parts of the north experience unusually mild, snow-scarce winters. One climate event, two continents, completely different consequences. In Australia, El Niño acts like a giant blowtorch. Temperatures rise, rainfall drops, soils bake, pastures shrink. And as vast stretches of vegetation turn dry and brittle, the risk of explosive bushfires rises dramatically. Thousands of miles away across eastern and southern Africa, the crisis takes a different form. Delayed or weakened seasonal rains threaten harvests of foundational staple crops, like maize and sorghum. For millions of families who survive on subsistence farming, a single failed rainy season can trigger severe, widespread food insecurity. Different continents, the same ocean signal, the same rising threat. El Niño doesn't just change the weather, it reshapes the global economy. When droughts and floods destroy harvests, the world's food supply tightens almost overnight. Rice production and exports from parts of Asia can decline during strong El Niño years. Coffee and cocoa crops suffer. Sugar and palm oil production can also decline. As global supplies shrink, commodity prices surge. Food manufacturers pay more for basic ingredients. Grocery stores raise their prices. And families everywhere feel the sting at the checkout counter. For national governments, the crisis runs deeper. Soaring food costs push up national inflation, forcing central banks to keep interest rates elevated for longer. What begins as a warm patch of water in the middle of the Pacific Ocean ends up shrinking household budgets right across the globe. Unlike past generations, we no longer have to wait for El Niño to strike before we see it coming. Today, an array of deep-sea buoys, weather satellites, and supercomputer models monitor the Pacific around the clock, tracking the smallest shifts in ocean temperature in real time. That early warning gives farmers precious time to shift their planting schedules. It gives cities time to protect their water supplies, and it gives governments time to prepare for floods and droughts. But prediction is not prevention. We can forecast El Niño months in advance, but we cannot stop it. The question now is no longer whether its impacts will be felt, but how severe they will become. A single shift in the Pacific Ocean can reshape weather across continents, disrupt economies, and change the lives of billions. Far out at sea, that story is already unfolding. This is the untold story of El Niño 2026.